Hello everybody, I'm eDoc2020, and this is a broken laptop power adapter. Can we fix it? Let's find out. The most common issue with a laptop power adapter is a broken output cord, especially right where the cable goes into a non-right angle power connector like this. So how do we test that? Well, first you want to unplug the adapter and give it some time to discharge just in case the actual circuitry is working. And then we can take a meter or a digital multimeter in diode test mode. And what you want to do is measure the plug in both directions. Actually, let me get out a digital meter. So what we want to do is we can connect the probes normally to the adapter. We see it charging up and reading open circuit. So that's normal. It's telling us it's actually connected. But if we didn't see it charge up and it just showed open, how else could we test it? We can connect the probes backwards. And it will settle at a small voltage drop, like a Schottky diode, so every like 0.1 to 0.3 volts. That tells us it's working. If the drop was 0 volts, we'd know it was shorted. So now, you know the problem's inside the brick, let's get into it. So most power bricks are like plastic welded shut, but fortunately this one's not. This just had 4 rubber feet, and under them were a screw each, and then this just comes apart. And now we can do a quick inspection. First thing we can do is smell it. There's maybe a slight tint of burnt electronic smell, but not much. Except this has also been dead for some time, so don't know what's up. And if you do like a visual look, you know, looks pretty good quality. The capacitors all look fine, at least what we can see. So digging further, I think we'll need to take off a bit of the shielding or heat sinking on here. One layer's removed so far. Didn't reveal much. It looks like to get the next part off, we'll need to desolder this. So now that we're in, the first thing we probably want to check is the fuse, which is right there. These 2 pins are the fuse. And the fuse is good. I'm going to check to see if there's any voltage on the main capacitor once I plug it in. It's plugged in. So now, very carefully, that looks good. possibly a bit low. That looks more like 140 volts, but I'd expect 160. We're adventurous. You can also see how quickly it discharges when we unplug it. That was almost instant. So I'm wondering if that capacitor is bad. I'm going to go desolder it and test it. I have the capacitor removed and hooked up to my AVR transistor tester. Let's see what it says. I don't know if you can read that, but it says capacitor of 1274 picofarads. And this capacitor is supposed to be 180 microfarads. So that's definitely our problem. Now we just need to find a different capacitor. The closest I have is 390 microfarads. Let's make sure this one's good. This says 331 microfarads, ESR 0.32 ohms. That's good enough. You can see the pins are the same spacing, although the physical size is slightly different. But it should be okay for testing. So I'll go put this in. Three, two, one. It doesn't light up now. To do a bit more troubleshooting, I connected the multimeter across the new capacitor. Now let's plug it in and see what happens. Should see about 170. And this is showing up as about 155, which is much better than before. And I know this meter isn't super accurate. Now let's see how quickly it stays, or how quickly it goes away when we unplug it. You can see it takes much longer to discharge. So the capacitor is doing its job now. Why isn't it working? After staring at the circuitry for a bit, I realized I was wrong about something. This actually appears to have power factor correction. I had neglected to count all of the transistors. So what happens is power comes in here, and well, it's rectified here. Then this transistor, diode, and inductor form a boost circuit for the boost active power correction. So if that's working right, we should actually see significantly more than 170 volts. There's also a chance that it only engages active power correction when the load reaches a certain level, so can't be too sure. But it's something to think about. I think I'll need to go look up some data sheets for the controller chips. I've made a discovery. So here's the power factor correction circuitry. And that's the power factor boost MOSFET. If I go from, what would that be, drain to source, get like a dead short. So that MOSFET is shorted. And ordinarily that would short out the power supply, but between the drain and circuit ground, there's supposed to be like a little tiny inductor which appears to have opened instead of blowing the power supply. I mean, like instead of blowing the fuse. So Hopefully that's all that's wrong, but I'm not sure. So my theory of what happened is the capacitor failed, like becoming open circuit. And then when the boost circuit would release its charge, instead of charging the capacitor, the voltage would just shoot up way too high. And then those high voltage pulses fried the MOSFET. And then, well, hopefully it didn't fry the controller too. I did some more poking around with the power factor circuit. I took out the MOSFET, and I also removed the chip so I could get a better view of how it's wired. And so in addition to the FET being shorted, we have this resistor in the drive circuit for the MOSFET, as well as this resistor in its feedback that appear to be blown open. And we also have, well, this was my fault, but this Zener diode is physically damaged. I was trying to get all the gunk off and it broke. So, with the drive and the feedback resistors being blown, there's a good chance that put enough current through the PFC chip to destroy it. In which case, well, probably not going to be fixing that, but there's only one way to find out, I guess. So I was just repopulating, like replacing some of the bad components. I also decided to check the rest of the electrolytic capacitors. You know, just because we had one bad one. Most of them are good, except this one is showing up as 290 ohms ESR. That's crazy bad. Okay, I have all of those parts replaced except for the MOSFET. What I'm going to do now is power this through my dim bulb tester. I want to see if I can see if the PFC chip is generating its own power supply properly. Looks like the chip's making a bit less than 5 volts. So obviously something's wrong. And I don't think it's worth replacing the PFC chip and then just to see other stuff fail too. So I mean, if I had one of those chips, then maybe. I guess I'm fortunately going to need to give this up. Hopefully I'll have better luck the next time you see me. Until then, I'm eDoc2020. Thanks for watching, and feel free to like, subscribe, comment, and share. Goodbye.